All right, so let's talk about graphing some parabolas. So we spent the last, it's not the last class, but a few classes ago, we spent a good amount of time solving quadratic equations, finding the solutions by either factoring or by using the quadratic equation. And today what we're going to do is we're actually going to graph those equations. And I should say the points that we found where we were solving the equation equal to 0, those are going to correspond to finding the x-intercept of the graph. But we're going to try and get a bigger picture here. So let's start off with kind of the one graph everyone should know, or if you don't already know, will know now. I'm trying to stand on, I remember I said I was trying to stand on this side of the board. It's just so much easier to write this side, but anyway. So we're going to graph everyone's favorite parabola, not y equals y. That's not everyone's favorite parabola. It's y equals x squared. This kind of is a little bit sad, sorry. Okay, so I don't care so much about your parabola being super precise, just like I don't care about your line, right? As long as you have the right shape and the right important points, that's what matters. This parabola, the parent of all parabolas, really, if you want to use that sort of language, you could plot a few points if you wanted. There are some x and y values. Typically, we're going to plot integer values unless there is a reason not to. So we're going to pick like x equal to 0 and 0 squared is 0. I think that's everybody. And we're going to pick x equal to 1, and 1 squared is 1. X can be 2, and 2 squared is 4. And actually, x can be positive or negative and still get the same result. So x could actually be plus or minus 1, and plus or minus 1 quantity squared would equal 1. And if x was plus or minus 2, then plus or minus 2 quantity squared would be 4. X is plus or minus 3, plus or minus 3. Either way, when you square a positive or a negative number, you get a positive result. So here's what the graph looks like. Now, normally I would draw the graph in the following way. So there's my x-axis, and the parabola is just going to have that shape. And I would just draw the parabola. I wouldn't plot all these points. Here I'm going to plot the points just to get a slightly nicer picture. But generally, I don't want you to plot all these points. There's only like 2, 3, or maybe 4 points you're going to want to plot when you graph a parabola. So here I'm trying to be a little more precise. Oh, I know what I want to say. On the homework assignment that is due on Thursday that I just posted up today, in Gradescope, there's only one file you can grab, and it has your XY coordinate systems with grid lines on them, like the horizontal and the vertical lines. But if you want to go to Canvas instead to get the file for the assignment, there are 2 different options, one that has grid lines and one that doesn't. While I like the grid lines for making my graphs more precise, sometimes they get in the way of the freedom you like to have of not having them. So I'll talk more about that as we go along. But if you use the one with grid lines, you kind of feel like you have to kind of be like, okay, it's actually supposed to be here. Whereas if you're not using the grid lines, you can just like wing it. So anyway, this is kind of akin to using the grid lines. I'm at the point 1, 1, 2, 4, 3, 9, and then negative 1, 1, negative 2, 4. This is already so much more work than you want to do. So there's the shape of our parabola, and parabolas should have the usual nice parabolic shape, which looks like this. Wow, that's not the best parabola I've ever drawn. Also, there are graphing tools like Desmos. I would encourage you to use them as checks, but this is what our parabola looks like. I feel like I've drawn too much of it. I usually don't go all the way to the top of the page. It's kind of silly that way. I would probably graph about this much of it. There's my parabola. And clearly I blew it down here, right? This should be my, kind of like that. Anyway, so parabolas all have this sort of shape. Sometimes they're a little bit wider Sometimes they're a little bit narrower, but this is kind of the shape, or turned over. That's kind of it. So we're going to graph a bunch of parabolas, and I'm going to kind of tell you the 3 things you need to think about when you're graphing a parabola. 3, maybe 4, I don't know. We'll do some examples. I guess I should say a couple more things just to point out here. So this bottom point on the parabola is called the vertex. And in this case, it is just 0, 0. In this case, it's the same as the y-intercept and the x-intercept. That's not usually going to be the case, but it is here. So, too loose, all right. When we graph a parabola, or when I graph a parabola, when you graph a parabola for me, I want you to find a few things like the following. So let's graph y equal to, what do I got here? X squared minus 6x minus 7. And this example is going to take a little bit more effort because we have to kind of talk about how you get all the things. But then after that, it's easy. So first and foremost, the number one thing we care about when we're graphing a parabola is the vertex. The vertex is the most important point on a parabola, without a doubt. Right? No argument, vertex is the most important for a parabola. How do we find the vertex? Well, you might know, if you've seen this before, that you can find the x coordinate of the vertex, which I like to write as v sub x, as negative b over 2a. And in this case, that would be negative 6 over 2 times 1, because my b value is negative 6 and my a value is positive 1. That's going to be 6 over 2, which is 3. And then the y coordinate. So here's the nice thing. Once you know the x coordinate of the vertex, you can find the y coordinate by plugging in x. So the y coordinate of the vertex, which I call v sub y, we just plug in v sub x equal to 3. Or really just x equal to 3. So if I plug that in, I'm going to get the y coordinate is going to be 3 squared minus 6 times 3 minus 7. So that's going to be 9 minus 18 minus 7, which is negative 9 minus 7, which is negative 16. So my vertex here is the coordinate x is 3, y is negative 16. So that's how we find the vertex. And that's always going to work to find the vertex. You always take the x coordinate to be negative b over 2a, and the y coordinate to be whatever you get when you plug the x coordinate in. Now, usually I'm the kind of person that likes to try and explain why things work the way they work. I don't just like saying this is why it works, or this is something that works and it just works. So let's talk about why this works. And the reason that this formula, this equation for finding the x coordinate works is because of a thing called completing the square. So we're actually going to take this parabola, and for this one and this one only, we're going to complete the square. I don't know if you've completed the square lately. It's something you often have to do if you're dealing with circles or equations of circles. So if I've got y equal to x squared minus 6x minus 7, the way we complete the square. Sorry, quick question. Is it weird for me to like talk off camera like this? No? Okay. If it is weird, let me know. I'm like, looking like, there's just no one talking. Okay. So, So, the way we complete the square is we take the coefficient of x, so we take the b value, and we divide it by 2. So, we're going to take this negative 6 divided by 2, and we're going to square it. That's going to equal, let's see, negative 6 over 2 is negative 3, squared is positive 9. And so then what we're going to do is we're going to add that in. We're always going to add in the thing we've completed. But the thing is, you can't just add 9 without changing things. So we can either add 9 to both sides. Right? One option would be to do this. Y plus 9 equals x squared minus 6x plus 9. minus 7. But the more typical thing in this kind of problem is to just add 9 and also subtract 9 on the same side. So it's more normal to write it as x squared minus 6x plus 9 minus 9 minus 7. So that I didn't actually change anything, right? This equation and this equation are still exactly the same. This one I just threw in an extra plus 9 and minus 9, which is just adding 0. And then the whole reason for doing this, sorry, I feel like I'm not getting my facial emphasis. The whole reason for doing this is because when you've added on that b over 2 quantity squared, this thing here factors, and it factors as a quantity squared, right? Because if you're looking to, so if you're trying to factor this, you'd be looking for numbers that multiply to 9 and add it up to -6. And those numbers are -3 and -3. So we could write this as y equal to x minus 3 times x minus 3 minus 16. And then you could write it as y equal to x minus 3 squared minus 16. So here's the deal. This number here, this -6 over 2, came, it's really, right, this stuff, sorry. Wow, I'm having a hard time using that pen here. That number, that is your negative b over 2a. And our vertex, if we look at it this way, so the vertex of a parabola is either the highest point or the lowest point. If it opens upwards, it's the lowest point. If it opens downwards, it's the highest point. In this case, it's opening upwards, it's the lowest point. But if we look at this expression here, y equal to x minus 3 squared plus 16, x minus 3 squared is always going to be greater than or equal to 0. Which means this is going to be opening upwards, right? This can't be any smaller than what we get if this was 0. What's going to make this the smallest? What does x have to be to make this part as small as possible?
Three.
Yeah, exactly. Right, if x is 3, 3 minus 3 is 0, and 0 squared is 0. And any other choice for x is going to make this bigger. It's going to make it positive, right, because it's squared. So the smallest value is when x is equal to 3, and y is equal to, if I plug in 3, right, if x is 3, 3 minus 3 is 0, and 0 plus 16 is 16. And that's exactly the vertex, right? If you look back to the other side of things, oops, did I make a mistake? I did make a mistake. Sorry, my minus sign turned into a plus sign, right? Because my vertex really is supposed to be 3 negative 16, which it would be if I had had the sign right here. Apologies. So this thing is the smallest when x is 3 and y is negative 16. And then any other value of x is going to make it get larger, larger, and larger. So let me kind of sum up here real quick before we graph this thing. The vertex, so I don't want you to do this every time, right? Because one, if this number isn't even, it's a lot messier of a process. And two, it's just faster to do it the other way, right? So you can always say, okay, I know I'm going to get the x coordinate by doing negative b over 2a. But you can also see that whether we do negative b over 2a to get 6 over 2, which is 3 here, or we get it from doing it like this, it's still 3 in either case. So it really is the same thing. So not that that's a full kind of proof of why you can do negative b over 2a, but at least it's offering some evidence as to like, oh yeah, it makes sense that this kind of thing works. All right, so we've done all that work. I'm gonna erase some of this here, because I do need the room to graph the thing. So we found our vertex. It was 3, negative 16. The second thing you always want to find is the y-intercept. And the y-intercept is usually going to be super easy. You're going to plug in 0 for x, and then you get y equal to 0 minus 7. or 0 squared minus 6 times 0 minus 7, which is just negative 7. If your quadratic is written in the usual ax squared plus bx plus c form, then the c value, the constant value, that's going to be your y-intercept for quadratics. So 0, negative 7. And now here's the thing that I think is really valuable. At this point, before you even think about x-intercepts, plot these points. So stop and plot. By the way, this is a good example of where I really wouldn't want the grid lines, because if I'm making each line worth like 1 unit, I have to go all the way down to negative 16, which at least the grids I have given don't even have that many lines. So here's where I just be like, okay, I'm just going to kind of eyeball it. So I'm going over 3 down negative 16. So maybe like here, there's my vertex. And then my y-intercept is 0, negative 7, which is here-ish. But I really don't want like all those little marks, right? That's not going to help me here. So now here's the thing. Maybe you don't know which way this opens, right? We saw that this was a minimum because of what we did on the other side. But now knowing, so without any of the other information we've had, if you know that the vertex is either the top point or the highest point or the lowest point, and you know that the y-intercept is higher than it, then you know that the vertex has to be the lowest, which means it has to open upwards. You might also know this because you can see that the coefficient of x squared is positive. And if you have a positive a value, it also opens upwards. So the reason I like to plot these 2 points right now before I think about x-intercepts is because if I found that this was opening downwards, I wouldn't have any x-intercepts and I couldn't find them if I tried. So I think it's really, really good to do this first and be like, oh yeah, I have x-intercepts. I can even graph the thing. Whoop, I can try my graphing skills. The problem, you know what the problem is? I'm trying to stand this like straight. I stand it like this. Yeah, that's okay. I've drawn better. It looks a little. They should always look symmetric about your vertex. It's a little bit better. So now I can see there clearly are x-intercepts. So I should actually go and find them. But if there aren't x-intercepts, you shouldn't waste your time trying to find them. If you do, what will happen is you'll start trying to solve a quadratic equation, and you'll use the quadratic formula, and you'll get imaginary results. Okay, so then we do the x-intercepts, if we have them. So we're going to set y equal to 0. So we've got 0 equal to x squared minus 6x minus 7. We don't know why I put a parenthesis there. We don't need it. And then this factors as x minus 7 times x plus 1. And if that's equal to 0, then my solutions are x equal to positive 7 and x equal to negative 1. Which is good. It looks like, right, the points I have look like they make sense with those values. So that's going to be 7, 0. And that's going to be negative 1, 0. That pen on my hand. A couple observations I would like to make you aware of. Room. Sure, I can write stuff on board. So one observation, the minimum value of this function is negative 16, right? That is the smallest value that the output can be. I would also say the minimum value of this function occurs at x equal to 3. So when you're talking about where a point is or what a point is, the where is the x value and the actual value is the y value. So if I say where is the minimum, the answer is at 3. If I say what is the minimum, the answer is negative 16. Because when you ask what the minimum is, you're talking about the minimum value that the function is. So the x is the where, and the y is the what. two other things. There's always an axis of symmetry, and it always goes through the vertex. So the axis of symmetry here is the vertical line, x equals 3. And the thing that I think is actually kind of really worthwhile, because it helps me know if I've got my intercepts right, is that from the axis of symmetry, the intercept should be equidistant on either side. Meaning the distance from 3 to 7 here is 4, and the distance from 3 to -1 is also 4. And that should always be true. The middle of your x-intercepts, if you have x-intercepts, should be the axis of symmetry where the vertex lives. Okay. And now it's just more examples. Also, please ask questions if you have them. Okay. Let's look at another example. All right, let's look at the next one. We're going to graph y equals to -x² plus 2x plus 3. And I know a lot of people, when they see a parabola or a quadratic, the first thing they want to do is factor if they can. That's fine, but I don't really want it factored for the vertex stuff. So we're going to factor it for sure if possible. I just don't do that first, but it's okay to factor it first. But first things first, vertex. And it's always the x coordinate first. So I don't know if I love being so far off camera. I might have to move things just a little bit so I'm not always off camera. I'm not good at writing like this. Maybe write like this. Figure it out. That's a little better. Yeah, okay. So the vertex here, the x coordinate of the vertex is going to be -b over 2a, which is -2 over 2 times -1. And -2 divided by -2 is just +1. The y coordinate, you're just going to plug that in, right? So plugging this in for x, that's how we get your v sub y. So we're going to be extra careful here. I've got -1 squared plus 2 times 1 plus 3. And here, this term, this -1 squared, since there isn't a parentheses around the -1, we're squaring 1 and then doing the negative after. So this -1 squared ends up being -1 because it's really -1 squared like that. So it's -1 plus 2 plus 3, and -1 plus 5 is 4. So my vertex is going to be the point -1, +4. Everybody, what's the y-intercept? Anybody, what's the y-intercept? Nobody?
3, 4.
It is. I heard 3. I think I also heard 4, but it is definitely 3. So the way we find the y-intercept is by setting x equal to 0. If you set x equal to 0, this part's just 0, this part's just 0, and you get 3. Right, because 0 squared is 0, 2 times 0 is 0, and 0 plus 3 is just 3. And in general, I'll just say this again, the y-intercept, if it's written in the usual standard way, the y-intercept is always just going to be that last value there, the constant term. All right, and then before we find any x-intercepts, if there are any, we're going to start graphing it. So, yes, yeah. Should draw straight. That's worse, oh well. So vertex is at -1, 4. So we go left 1, up 4, so about there. There's my vertex. And my y-intercept is at 0, 3, so maybe like right there. it is really, really important that when you do graph these points, you pay attention to which y value is larger, and you make sure that you plot that one higher. If you don't, it's going to be a problem. So I see that my vertex is higher than my y-intercept. So my vertex is the highest point, right? Because the vertex is either the highest or the lowest, and it can't be the lowest because that's lower. So the vertex is the highest point, which means it opens downwards. Or you could use the fact that if the coefficient of x squared is negative, it opens downwards. There's two different ways of doing the same thing. There's probably other ways as well. So we know we are going to have x-intercepts because this is going to be the highest point, and we're going to go down like that and like that.
I had a question.
Yeah.
How do you get -1 for the vertex, the -1, 4, when you originally got 1?
So, oh, because I'm not paying attention. That is an excellent question because I made a mistake. Yes, good point. So actually my vertex would be over here at +1, 4. We still have the other stuff being the same. Yeah, you good. Wow, yeah. I definitely got caught up with the -1 talk over here and kind of just was not paying attention. So yes, my vertex is +1, +4. Good catch before we got too close to being done with that. Thank you. Let's get that on there correctly. So my vertex is actually over 1, 4, so like right up there. My y-intercept is still at 0, 3. We're still opening downwards because negative coefficient, or because this is the highest or the lowest, and it can't be the lowest, so it has to be the highest. So we're going to do this kind of deal. When you graph these, do try to make the point near the vertex somewhat rounded, right? It shouldn't be super pointy. It should have a nice, like, smooth curve. So we do see that we have x-intercepts. And now here's the part that people find challenging. I'm trying to find the x-intercepts by solving this -x² plus 2x plus 3 equal to 0. And what I really want to do, so, well, I'll say this and I'll talk more. I hate having this negative sign here, right? It really makes it challenging for me, at least, to factor this without having a brain meltdown. So if I'm trying to solve an equation, it is perfectly okay to divide both sides or multiply both sides by -1, or by any number really, but specifically here -1. So if I multiply everything by -1, I get +x², I get -2x, I get -3 equal to -1 times 0 is still 0. And then I can factor this. Factor x -3 times x plus 1. So I get x equal to 3 and x equal to -1. Again, these seem reasonable, right? I've got a -1 there, -1, 0. I've got a +3 here. And -1 and +3 are both the same distance from 1, right? 3 is 2 to the right, and -1 is 2 to the left. And that should always be true if you have x-intercepts, that they should always be equally spaced to the left or right of your axis of symmetry. My axis of symmetry is the vertical line x equal to 1. Couple things to say here. Yeah, I have a maximum value. Right, this one definitely has a maximum because there's a highest point. There is no minimum. There is no lowest point. You keep going down, down. So it has a maximum value of y equal to 4. It has a maximum value at x equal to 1. So the maximum value occurs at x equal to 1 with a value of y equal to 4. The other thing I want to say here, this is kind of important, and this is actually, especially for ones with a negative coefficient out here, why I don't like to start with factoring. Because if I start with factoring and trying to solve this equation, sometimes I forget the fact that I divided both sides by a negative, and I've definitely seen students and myself say, oh, I'm just going to graph this, y equals x squared minus 2x minus 3, which opens upwards. So be really, really careful, right? If you've got a negative out here, it means it has to open downwards. And if you factor it out, it's okay to solve an equation, but it doesn't just go away when you're graphing the thing. All right, more examples. I feel like this example I put in the homework, but oh well. Okay, let's do a couple quick ones. So let's graph the following one. Y equal to x squared minus 5x minus 6. And again, first things first, the vertex. Here things are going to be less nice because our vertex x coordinate is going to be a fraction. All right, so the x coordinate is going to be negative 5 over 2 times 1, which is 5. And I definitely recommend leaving this as a fraction because you're going to have to square it, and it's much easier to square fractions than it is to square decimals. The y coordinate, I'm just plugging this in. Also, I will point out, sometimes, and I definitely in the homework, I use this function notation instead on some of the problems, right? I can call this f of x. Same idea. And then I can say that I'm going to find the y coordinate of the vertex by plugging in 5 halves for x. So I can say, oh, that's going to be f of 5 halves. And then I'm just putting this in. So it's 5 over 2 squared minus 5 times 5 over 2 minus 6. All right, 5 over 2 squared. When we square a fraction, we just square the top and the bottom. So we get 25 over 4. Minus 5 times 5 halves is minus 5 over 1 times 5 halves, which is minus 25 over 2. Just top times top, bottom times bottom. And then it starts with minus 6. So now I need a common denominator, and that common denominator is going to be 4. So this is 25 over 4. I'm going to multiply this by 2 over 2 to get 50 over 4. And I multiply 6 by 4 over 4 to get 24 over 4. So 25 minus 50 is negative 25. And negative 25 minus 24 is negative 49 over 4. So my vertex is 5 halves, comma, negative 49 over 4. I also want to mention, just because I've seen people make this mistake on occasion, be careful when you've got subtraction, right? You can't say 50 minus 24 is positive 26 because you don't have 50 here. You have negative 50 minus 24. So just be a little extra careful if you've got subtraction. You're going to do. All right, let's see what kind of thing we've got. Oh, I still need to find the y-intercept. All right, I'm gonna try everybody again. Everybody, what's my y-intercept? Nobody?
-6.
Yeah, thank you. Somebody, thank you. Yes, y-intercept definitely -6. Someone's like, oh, fine, I will say words. So then we start graphing the thing. The y-intercept is down here at -6. And my vertex, negative 49/4. Well, I know that 48 is a multiple of 4. It's 12 times 4. So 48 over 4 would be like negative 12. So negative 48 over 4 negative. So this is pretty close to negative 12, which means it's way more negative than negative 6. So we're over at 5 halves, negative 12-ish. Really, it's 5 halves, negative 49/4. Which means our parabola has to open upwards. So it's got to look something like this. And then we're just going to fill in the x-intercepts. Start to go. So we're going to fill those in. So I'm going to use this real quick. Problem with these is there's so much information to put on the board. So x-intercepts, we're just going to set our x squared minus 5x minus 6 equal to 0. And it does factor. Factors x minus 6 times x plus 1. So my intercepts are positive 6 and negative 1. So this point is negative 1, 0. This point is positive 6, 0. And once again, I will just note that they are equally distant from the axis of symmetry, right? They're both the same distance from 5 halves. 5 halves are, 5 halves or 2.5 if you like, where it's 3.5 to 6 and it's 3.5 to negative 1. So yeah, that works. I also will post these on Canvas, like the ones that I've written out here. There's definitely going to be a couple examples we probably don't get to. That's all right. I will say it's essentially the same process every time. You find the vertex, you find the y-intercept, you look to see if you have x-intercepts, and then you graph the thing. All the examples I've been giving so far have nice intercepts, but you can also end up using the quadratic formula to find your x-intercepts. So let's look at this one. Let's look at f of x equal to x squared plus 4x plus 5. So to find the vertex, and so it gets a little old, right? It's like the same thing over and over and over again, and sometimes it gets a little bit boring. That's all right though. Math isn't always exciting. I know you thought it was, but it's not. It can be exciting a lot, but there's a lot of cool patterns. So vertex, so the x coordinate is going to be negative 4 over 2 times 1, which is just negative 2. The y coordinate is going to be f of negative 2, which is negative 2 squared plus 4 times negative 2 plus 5. So be careful, right? This is different than the negative 1 squared that we have, in that here it's negative 2 quantity squared. Before it was 1 squared and then the negative of that. So here you're going to get positive 4, and then 4 times negative 2 is minus 8 plus 5. 4 minus 8 is negative 4. 5 is negative 9. Let me try that again. 4 minus 8 is negative 4, plus 5 is positive 1. My vertex here is negative 2, 1. My y-intercept is the point 0, 5. Because if you set x equal to 0, y is going to equal 0 squared plus 4 times 0 plus 5. Which is 5. Then we plot these points before we even think about x-intercepts. So let's see, I've got 0, 5. I should have given myself more room on the left because my vertex is to the left. So let's draw this again. So I've got 0, 5 as my y-intercept. This, for some reason, I decided to make marks this time, and I've got negative 2, 1 as my y-intercept. Sorry, as my vertex. So clearly this one opens upwards because my vertex is right there, and since there's a point above it, my vertex is the lowest point. Or again, you can just say we have a positive coefficient, so it's got to open upwards. So that means I don't have any x-intercepts. A lot of people don't love when we don't have x-intercepts because it can feel slightly harder to graph the thing because you really only have 2 points. So when you have the situation where you only have a vertex and a y-intercept and no x-intercepts, what I usually end up doing is plotting one more point. And there's a specific point I always look for. So I can see that from my vertex, which is negative 2, 1, to my y-intercept, It's 1, 2 over and 1, 2, 3, 4 up. And the vertex is in the middle of this symmetric, like it's on the axis of symmetry. So I know that if I go 2 over and 4 up, I can also do the same thing to the left and get another point on my graph. So instead of going over 2 and up 5, I'm going to go over 2 to -4 and up 4 to +5, right? To value 1. So I can kind of just mirror that point. Right? That's what I'm kind of doing. I'm saying if I've got this point here, I can flip it around and say also have that point there because of the axis thing. And that just makes it a little easier to screw up your graph. This is why I don't like to maybe make all the marks, because I'm usually not good at making sure it goes to where I want it to. That's a little better. Yeah. One thing I will say about graphing these things is make sure that when you hit the y-intercept, you do cross from left to right, right? You can't just kind of like run up against the y-axis. You have to cross, like where I'm here on the left, I'm on the left, I'm on the left, and then I hit my y-intercept, and now I'm on the right side of the y-axis. Here, the minimum value is y equal to +1. That is the minimum value of this quadratic or this parabola. Okay, I think we got time. We got time for one more. So yeah, sometimes you'll have no x-intercepts, and that's definitely easier to finish. I think there's something else I might want to say here. I don't think so. Let me double check. Oh, I know. So let's pretend for some reason that we decided not to do it the excellent way I should do it, and wanted to find the x-intercepts first, right? If you started trying to find the x-intercepts, you would be setting x squared plus 4x plus 5 equals 0. It doesn't factor because you can't multiply to 5 and add it to +4. So instead, we try using the quadratic formula. And if we use the quadratic formula, we get x equal to -4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2. And here we see that, oh, that's 60 minus 20. That's a negative number inside the square root, which means we don't have real answers. So if for some reason you start trying to find x-intercepts, you will find out they don't exist because you'll get answers that are not real. So if that ever happens, like, oh, it makes sense. But it's easier just to graph the other things first and be like, oh yeah, this couldn't possibly have x-intercepts. If my vertex is above the x-axis and my y-intercept is above that. Yeah, we'll do one more, and then there's a couple more at the end of the notes that will be on Canvas, and you can look at that as well too. So let's try graphing f of x equals to 2x squared minus 5x minus 3. I will say that all the examples that I'm doing today and all the homework problems that I've given you, if there are x-intercepts, they're not irrational. They're all either nice whole integer numbers, or some of them will be fractional numbers, but there's no like square root of 7 or anything like that. So that maybe isn't super realistic, but that's more what I wanted to give you guys to work on. So maybe that's my own bias. Let's find the vertex, which is kind of a pain here. The x coordinate is going to be -5 over 2 times 2, which is 5 fifths. Fractions. Yeah. All right. Y coordinate, that's going to be, you just plug in 5/4, so you get f of 5/4, which is 2 times 5/4 squared minus 5 times 5/4 minus 3. All right, we need to do some work here. So 5/4 squared is going to be 25/16. So I get 2 times 25 over 16 minus, so 5 times 5/4 is 5 over 1 times 5/4, which is just 25 over 4, and minus 3. So common denominator, the easiest common denominator is actually going to be 8, because this 2 and the 16, I can cancel a 2 and have an 8 down there. So I have 25 over 8 minus, if I multiply this by 2 over 2, I'm going to get 50 over 8. If I multiply this by 8 over 8, I get 3 times 8 is 24 over 8. 25 minus 50 is negative 25. Negative 25 minus 24 is negative 49. And then we kind of got that last time too. Well, last time we got negative 49 over 12. Now we get negative 49 over 8. Something I've noticed, and this might help you, it might not, is when you're finding the y coordinate of the vertex, what is always going to happen is that the first thing and the second thing are always going to be opposite signs. And the second thing is always double the first thing. It's always true, right? It was true in the last example. First thing, second thing, opposite signs. Second thing is double the first thing. You can look back at your other examples too. You'll see that for every one of them, the first and second term, when you're only when you're finding the y coordinate of the vertex, the first and second term are always opposite signs, and the second thing is always double the first thing. So if you don't see that happening when you simplify, you might want to check your work. Okay, I know we're almost out of time, so we'll finish this off here. My y-intercept is obviously negative 3. So graphing this, here's my y-intercept at negative 3. And my vertex, negative 49/8, well, negative 48 over 8 is negative 6. So this is close to negative 6. It's a little more negative than negative 6. So we're down here-ish. So we're at 5/4, which is a little bit more than 1, and negative 49/8, which is a little bit more negative. So there's my 5/4, comma, negative 49/8. This is clearly the bottom, since there's a point above it, so it's going to open upwards. I need to find my Xintercepts. And since we're just about out of time, I'll just find them real quick like here. So solving 2x squared minus 5x minus 3 equals 0. You could definitely use the method we've usually used to solve an equation like this, where you try to multiply to negative 6, not to negative 5. I'm just going to show you how it factors, because this one's not too terrible. So I know I have to have a 2x and a 3x. Sorry, a 2x and an x. And I know I need to multiply to negative 3. So I'm going to put the negative 3 here and the positive 1 here, because that's going to give me a positive x and a negative 6x, which definitely adds up to negative 5x. There are other ways to do this. So we're going to get x equal to 3 and x equal to negative 1/2. So that's how we would graph this one. And this one would have a minimum value of negative 49/8.